So this is the 2015 Leaving Cert Ordinary Level Paper 1, and we're looking at question number 5. The diagram shows the graph of the function f of x is equal to 5x minus x squared in the domain where x is between 0 and 5 inclusive, and x is an element of the real set of numbers. So here's our function f of x, and part A says the function g is g of x equals x plus 3, where x is an element of the real set. The points A, which is 1, k, and B are the points of intersection of f and g. Find the coordinates of A and B. So we're looking for the 2 points, or the two coordinates where the function f of x and g of x intersect. Okay, so you could do this graphically. You could draw the function g of x is equal to x plus 3, or you can do it algebraically. I'm going to do it algebraically, so we're looking at where f of x is equal to g of x. So f of x is 5x minus x squared, and g of x is x plus 3. So if we bring the x over there, it becomes a negative x. And if we bring the positive 3 over there, it becomes a negative 3. So we end up with minus x squared. 5x minus x is 4x. And then we have the negative 3, and that's equal to 0 on the right. So we can change the sign of all of that to give us x squared minus 4x plus 3 equals 0. Now you could solve this by quadratic formula, but it's an easy one to do by factorizing, so I'm just going to do it by factorizing. Just go up here. I'm going to split that into double brackets. So factors of 3, which when added or subtracted give us minus 4, well that would be 3 and 1. Positive 3, positive 1. Or sorry, it would be negative 3 and negative 1. So negative 3 and negative 1, because minus 3 multiplied by minus 1 is plus 3, and minus 3 minus 1 is minus 4. So equal to 0, so then when a bracket by a bracket is 0, well then one of the brackets must be 0. So we look at that. If x minus 3 is 0, well then x must be 3. That's one x value. And if x minus 1 is 0, well that means x must be 1. So there's our two solutions of x. But we're asked to find the coordinates, so we need to know the matching y coordinates with those. So we can just put both of these x values back into either one of the functions. So I'm just going to use the g of x function, which is the easiest function to use. So let's look at g of 3. When I put 3 into g, I get 3 plus 3, which is 6. And when I put 1 into g, so g of 1, well that's equal to 1 plus 3, which is 4. So the points then, the point A, when you put 1 in, you get out 4. And the point B is when you put 3 in, you get out a value of 6. So there's my two answers there at the end, A and B. And you can see there A is 1, 4, and here we have A is 1 something k, so we know that that's along the correct line. So part B says the points O, 0, 0 and C, 5, 0 are on the graph of f. Part 1 asks us to draw the quadrilateral OCBA on the diagram above. So the point O is the origin and the point C is 5, 0. And then we have to draw OCBA. So here's the point O. Here's 5, 0 is the point C. And we have to put in B and A as well. So A is the point 1, 4, which is here. A, and B is the point 36, which is here. That's the point B. So OCBA is the quadrilateral, so let's draw that quadrilateral. So from O to C, oh sorry, O to C, OC, and up to B, OCBA, and finally back to O. So that's the quadrilateral that we were to draw. So that's part 1 done. Draw the quadrilateral OCBA. Part 2 says find the area of the quadrilateral OCBA. Okay, so if we're looking for the area of this shape, it's a quadrilateral, but you can split it up. So you could split this quadrilateral up as follows. You could split it into, let's see, so triangle here. And if you bring this line down here, so you have 3 regions. You've got this triangle here, you've got in here we have a trapezium, these sides are parallel, and then finally over here you've got another triangle. So if we find the area of those 3 shapes, which we have formulas for, we can find the area of the total quadrilateral. So let's have a look then. The area of the yellow triangle is half the base by the perpendicular height. So if we assume that this line here is the base, that's 4. So that's going to be half of 4 by the perpendicular height, which would be this height here, that's 1. And that's equal to, half of 4 is 2 by 1 is 2. So that's 2 units squared. That's our yellow area. Next we have the green. So if this green area here is a trapezium, the formula for trapezium is a half multiplied by one of the parallel sides plus the other parallel side, and then that's all multiplied by the height of the trapezium. So it's going to be a half of one of the parallel sides here, so that's 4, plus the other one, which goes from here up to there, which is 6. And then that all gets multiplied by the height of the trapezium, which would be from 1 to 3, which is 2. And that is equal to a half of 10 by 2 is 20, so a half of 20 is 10. So that there is our green area. Okay, and finally we're going to look at the blue area. That's going to be half the base. This time we'll take the base as this one. So that's a base of, from 3 to 5, a base of 2, so half the base by the perpendicular height. This time is from 0 up to 6, and that's equal to a half of 2 sixths, which is 12. A half of 12 is 6. So that's our final blue area. So when we add the 3 areas together, it's 2 plus 10 plus 6. So we've got the 2 plus the 10 plus the 6, and that gives us 18 units. It's not meters or centimeters, it's just units because it's on the XY axis, squared because it's area. And that's the end of B part 2.